I did BTech, MTech, and PhD. Then I also did some postdoc. Right now I'm associated with IIT actually. So I'm completely technology guy. Okay. So if you ask me the ABC of agriculture, I don't know. But I know data, right? Whatever previous person was asking, I know data, I know methods, I know AIML, I know technology part, but you are good at agricultural level, right? Okay. So the topic that I'm going to discuss in today's maybe throughout the day or maybe 3 or 4 hours. Particularly, I will be talking about precision farming, but not with respect to your domain. I will be talking in terms of automation, most probably. How do we automate it? As you can see the title, right, it shows revolutionizing crop monitoring and data collection in precision farming using smart drones and robots. And the good part is like this particular project was funded by my institute, IIT BHU itself, so that I can collect the basic required equipment so that we can perform some activities, right? Because this is the last days, right? So I just want, and I was informed many are first year, right?
Yes, these like students are from first year.
Okay, so we both are on the same page.
Yes.
So how can I say? Because I am also first year in agricultural domain, right? I'm just trying to explore a concept, right? How can we enable agricultural data in technology side? Okay. Is there BTech as well?
Yes, sir. Actually, they are more interested towards this area. That's what we
Oh, great. I was pretty much surprised, right? What I'm going to say with agricultural people, right? Because they are pretty much good somewhere.
So this batch wants to be known as AIs, rather than agriculturists. This is what they are targeting.
Great. So I think we can correlate with each other, right? And is it required to be here? This is being recorded, right?
Yes, yes.
So okay. Otherwise, I heard this one, so I can roam around. I
Sir,
prefer
that should be fine.
That's okay. So because this is the last day, so before starting my discussion, I just want to know what is meaning of precision farming.
Elimination of useless techniques, conventional techniques that
So how can you eliminate conventional techniques, right? My father is farmer. He is pretty much well known when my field needs irrigation. Right?
So precise and limited use of resources.
Yes. What else? I just want to know your background so that I can say yes. I can contribute in your domain, right? I'm just trying to understand the meaning of precision farming. Smart drone, okay, robots. Okay. I think being technical guys, you must be aware of data at least, right?
Yes.
What is data?
Information.
No, there is difference between information and data, right? I will pinpoint at the very narrowed way, right? I'm not just going to boom around, okay? I will be coming slowly. Data is raw fact, okay? What is information? Collection of data which can get some information, that's information, right? Which can give some meaningful fact. So this is basic difference between data and information. Okay. I know, let's roam around. So yeah, so before starting this particular point, I also want to advertise that earlier person did it for his company. Okay. Around half an hour he spent just to get that part. So let me going through this one. So this particular institute is coming from 1919 itself, and it established by one of the greatest person, like our Bharat Ratna Mahamana Pandit Madan Mohan Malviya ji, and this is a publicly funded institute. And in 1968 it started as become Institute of Technology, and in 2012 we got IIT. And it's beautiful campus located in Banaras Hindu University. Legacy over more than century now, you can say we are 2024 and 1919, so more than centuries we are. And advanced research across different domains. If you are ever coming in Banaras, you are most welcome to visit IIT. And we have interdisciplinary approaches. We emphasize on collaboration, innovation, other parts. And our main commitment is for upholding the legacy of academic excellence and innovation. And future goal is like expanding research, innovation, and global collaboration. And one more thing is common between your university and my university, right? So we both achieved 10th position somewhere in our field. Okay, I was just sitting in your dean's office, so I saw NRF ranking 10 in agricultural domain, right? So I was also willing to, I can also give a boom, I'm also on 10th position in engineering categories, including IITs, all IITs, ISC Bangalore's, and overall 30th in overall categories, right? So we are pretty much good, okay? And that's great. Now let's move ahead. So this is all about my institute. I already discussed myself. Now coming to content that I'm going to deliver in today's class, it is pretty much technology driven, not particularly the agriculture, but agriculture is one of the applications that I'm going to target. Other part is I'm not saying this technology will be just enabled in agriculture. It could be enabled anywhere where we are willing to get data remotely available and collect it and do some analysis. Okay? So I will walk you through. So traditional farming and challenges, as someone was saying, like we are trying to maximize the utilization of resources, right? So we'll see why do we need all this technology model. Then precisely we'll define particularly what is precision farming and why do we need UAV, because I must say, like you are already aware of in last 3 or 4 days. Then what are challenges, then existing works, and one of the solution that we have developed, and this solution is somehow theoretical as well as a prototype level we have examined in our lab. I will try to illustrate it, right? And this work has been published in one of the conferences, right? Okay, so are you ready? So in 2-3 slides I would like to just acknowledge this Shutterstock person. They have created very nice figures. So I have taken 3 or 4 figures from their websites. The reason why I am taking, because this is just trying to get what I am looking, I'm willing to convey, right? And they have very good figure collection, picture collection in their website or database. Okay. Anyway, so let's go ahead and just see what could be the interesting part. So traditional farming, I'm just going to start with older version. So we are saying we all almost grown up with traditional farming itself, because I'm also coming from the agricultural background, so I know at least most of things have been covered by the farmer itself, right? They know when they are going to do all these activities, right? When they are going to do watering, when they are going to spread chemicals, other things, right? But we are trying to maximize that particular portion, right? So conventional model is like maybe labor cost could be quite high, and we have machinery, but basic machineries are there. For example, maybe you can think of tractors, or in our times, or maybe 10 years, 20 years back, we have bale, other things, right? We used to roll around that one. And mainly relies on minimal reliable on the advanced technology, and relies on organic fertilizer, traditional irrigation. And 90% time if you visit store, right? So there is label you can get organic, organic part, right? So our old fathers and that person were doing all those things, right? Okay, from quite long, but now it has become one of the hallmark. Okay, now coming to what are the limitations, because someone has already figured out, right? What are the limitations, right? Earlier time, if you see, the number of farmers used to have quite large in numbers, but most of the farmers are now moving towards the cities, right, for their basic earning. So you know the reason is pretty much clear. Whatever investment you are going to do today, it may or may not give you the revenue after 3 months or 4 months or after 6 months, right? So this is fast area. No one wants to wait for 6 months just to get revenue or profit, right? And once you are going to get a revenue, you get to know the product that you have come up with. Similarly, the same product has been launched by many states. So your MSME, other that government is dealing on, the price goes down, right? So at that time, now common farmer doesn't have so much storage so that he can store and can sustain for another 10 or 12 months. So low productivity could be another one, limited control over water, fertilizers, pesticides, usage, often leading to excessive or insufficient applications, right? Also it may be low productivity. Sometimes farmer is not able to understand by what means his crop productivity goes down, right? High manual labor demands increased cost, strain, weather dependence, also insufficient pest management as well. So manually if you are just going to throw away the pest, you never know how, by what amount a particular plant is going to get the pest, right? So that becomes problematic part, right? So here you can see a particular farmer is sitting with his wife and he's not pretty much happy with the weather condition or whatever limitations we have discussed over here. The question comes, how should we make him happy? So if you see, so this is pretty drastic kind of thing, right? So if someone is just going to wait for 6 months but he's not willing to get whatever he was expected for, so become depressed, right? So you might be aware of many farmers are even becoming not doing all those things, right? They are not even coming in the field because of sometimes they get not desired outcomes. The only outcome that we are willing to from this transition to this one. It seems like he is not watching at least reels. Okay? Maybe he might have got some direction which can help him out in his farming. So what that particular direction is. So being engineers, it's our responsibility to make him happy. Okay? So to do so, here is the smart farming coming in the picture. It says, let's put around available facilities so that rather being depressed, he can do whatever activities he is trying to do happily. And that will increase his productivity as well. So smart farming, if you see, consists of irrigation with drones, security rover boat, planting boat, robot sinker, and many more. Right? So the question comes, how do we aggregate all those things? Because a common person or common farmer doesn't know, right? So being technician, we are willing to go in this particular direction. And that comes up with the term known as precision farming. So let us see what is precision farming. I know you are already aware of, and some of you already answered this question. But formally, I am just going to look around a picture which will give an intuition what is meaning of precision farming. So we are saying, it is not appropriate picture, but let me just give you the motivation. We are saying, let's assume there is a region which is not pretty much smooth enough to do the agricultural part, right? So we are saying in this domain we are just going to deploy a few sensors through which we can collect data, and because this is not pretty much good, so the tractor and the other parts can go every time and visit all these fields. So we are saying there should be someone who can collect data and give information to the farmer, so that farmer can utilize it for their productivity purpose, right? So we are saying for this purpose we will be using drones, which will help us out for collecting data from different parts in the field. And it is not just one drone, there will be multiple drones. Let's assume you are just covering huge area, right? Maybe 10 acre or something, right? So they can coordinate with each other and they can collect data. But there are some parts where your drone might not be able to visit. Maybe under tunnel or somewhere, right? Or some places where high trees, other parts are available, then your drones might not be able to work. So how do we rectify that part? We can rectify those parts with robots. Robots can collect data and they can work for us. So combining all three technologies looks pretty interesting, right? But do you think a particular farmer can afford all those things?
No, sir.
So let us make their life easy, right? Okay, so we are saying like everything could be connected through some server, and through server smart farmer or these devices can collect data, and accordingly they can get the required outcome when they are supposed to do what kind of activities. So particularly if you talk about the wording meaning of precision farming, this is not a standard one, but I try to keep some of the words so that they can make sense. So precision farming is the matching of resource application and agronomic practices with soil attributes and crop requirements as they vary across the field. Very happily loaded sentence, right? So, okay, so let's forget, but the only meaning is we are trying to get some data and trying to make some decisions, right? And the reason why we are trying to do all these precision farming, sustainable farming, all those things, so that we can monitor the crops, okay, with help of IoT-based sensors and real-time sensor data collection, improve crop production and soil health, and reduce human labor cost. So I can just go to the previous slide, right, where industry guys was just saying like he has developed some sensor which can collect data with help of satellite within a month or so, right? That's very good technology. But I'm wondering, right? So let's assume your crop is looking, there is a crop which needs attention within 10 or 20 days or within 1 or 2 hours even, right? Then such technology should be evolved enough, right? So we are saying if you talk about real time, so I'm saying with real time maybe certain interval of days or maybe 1 day or 2 days or 3 days, if you are able to get the data, so we are pretty much good to inform farmers, okay? So just to comparison basis, I'm not saying traditional farming was bad, I'm saying those were good on those days, but as per the current requirement, we need to smart enough them. So the reason in traditional farming we have a generalized often wasteful, so we are trying to maximize the efficiency. Productivity, we are trying to maximize productivity in certain areas, right? So for example, if you are trying to maximize in 1 square meter, so what is current productivity with respect to our precision farming? What was the previous productivity when we were following traditional farming? So we want to compare on those parameters, right? Manual power, labor intensive, we are trying to automate and we are trying to make life of laborers easier. And weather adaptability, we are trying to make, like, even if weather is not in a diverse condition, still we can get sufficient amount of crops, right? Minimal or intuition based, so we are saying the precision farming will be data driven and precise decision maker, right? Okay, so we are not saying less labor, so we are saying less labor in the sense if there would be less labor for doing the precision part, so maybe other rest of the laborers could be doing some other activities. So I can give you the example. So a few days back, I was just going through one of the articles by the Sundar Desai. You might be aware of Google CEO, right? So he was saying like more than 60% development or coding is being now done by the AI. So it means he does not need 60% developer, right? No, he needs it, right? For what? To develop another AI tool, isn't it? So I'm not saying we are just going to have less labor, we need labor, but just for the other purposes. Okay? So coming to another innovation is not going to reduce the manpower cost or something, right? It is going to make man free so that we can do some other activities. So quite few days back I was just going through one of the article not just like one line. So he was saying like I want AI to do my laundry so that I can draw some pictures, but I do not want AI to draw pictures, right? So the thing is like I want something to be done by AI, but at the same time I am also conscious something that I am willing to do should not be done by the AI. Okay. So let's go ahead then. Okay, so because we are talking data collection part, so if I say that what is need of UAE, UAV, it should be UAV or drone, whatever you say, like, those are synonyms nowadays in technology part. So I am considering area of field is quite large, and farmer is not going to visit in certain interval. He is not going to visit 1 day or 2 days, right? Because he has some other work to do as well. So from now onwards, if I say the use of UAV, I am saying area of agriculture is quite large enough. And manual attendance is not possible every day. Attending these crops or at least, right? So saying the rapid data collection is one of the good part, and this will give precision monitoring and automate the agricultural task, and also monitor the crop and soil analysis, irrigation management, planning and seeding, right? I will just go through very quickly what with the technical part, so that we both can come on the same page very quickly, because after 3 or 4 slides, most probably I will discuss in one of our papers, one of our work. So, but before that, I just want to give you the notion, right? So, fixed wing drones, multi-rotor drones, hybrid drones, single rotor drone, helicopters, other things, right? So, this is the picture that you can think of. These are hardware parts. It is pretty much suited for the industry people, like what kind of drone they are going to deploy in a field for data collection purpose. So being software people, we are pretty much concerned on data and software part. Okay. So there are several kind of drones, and some of you might have already seen in this particular duration, right? So I will not go in details. So UAV benefit, we know, like we do not need manual cost. Labor cost will be minimized, mobility and easy of reaching terrain and mountain regions, reduce waste of power, fertilizer and pesticides, and identifies issues early, improving crop productivity, cut labor cost, reduce soil and water pollution. So here is one topic where we can say how UAV is working out for betterment of farming. Increase the farming yield. Quick decision making by farmers. Drones are easy to maintain. Similarly, allocation of effective and efficient farming processes, and most of cases we get accurate part. Either we need to what we are supposed to do, and help collect evidence for the insurance claims during the crop failure, other parts. So this is not just for one thing is pretty much clear as well. We should think this is not with respect to farmer itself. Okay, this is also with respect to insurance companies who give insurances to the farmer, right? So sometimes what happens if the farmer is going to claim for the insurance, many times insurance companies say like, give me the proof. If things are automated, it would be quite easy for farmer to get his insurance done very quickly. Okay, because there will be less manual cost, so it would be quite good for the farmers as well. So we discussed UAV, which is helping us out for data collection. 2 more terms I discussed in this particular picture. One was the sensor, other was UAV. UAV already discussed, that's the biasness. So I will discuss sensor now, then after that I will discuss this robot. Okay, first I am just trying to build the concept the way I am going to flow, right? Okay, UAV part is clear. Now let's discuss sensor. I think, what is sensor? Sensor is a device which generally collects data, right? Okay. So, and what is IoT device? So one is sensor, we know that it collects data. Another is the IoT device, right? Your laptop, your mobile phone, or this camera, even this one is IoT device, right? It has sensor. It has. So have you wondered how many sensors your mobile phone has? You have touch sensor, you have voice sensor, right? You can control your mobile phone through voice. Okay? Around more than 20 sensors your mobile phone has. The more number of sensors your mobile phone has, it is going to drain your battery very easily, right? Very soon. Right? So it is pretty much clear what is the difference between sensor and IoT device. Sensor is a dumb device which just collect data. And IoT device is a smart sensor or collect collection of sensors which collect data. Also, it computes as well, and it can also make some decisions. Okay. For example, there is a room temperature sensor which can just collect the room temperature, right? And there is a device which can collect data from room temperature sensor, and accordingly it may maintain. For example, you talked about your AC, right? It has room temperature sensor. If you just set your AC on 25 or 26, so after a certain interval, what will happen? The sensor will be collecting data, and after a certain interval, there is controller which will, after getting sensory data, it will just try to maintain the room temperature. So if it is getting up, it will just try to get down the cooling part. If it is getting down, it will try to up the cooling part of your AC, right? So it is taking data and accordingly doing some computation part and making decisions, right? Okay. The same thing we are going to do in this particular process. So it is pretty much sure, like we are not just talking about sensor, we are also talking about the IoT devices. Then optimize water usage and fertilizers by providing precise data. As you see, the person was saying like there is a scarcity of water in Punjab region, right? So traditional farming is just keep on going. This might be problematic. So we are trying to overcome with that particular problem. It also gives the informed better decision making to boost crop yield and quality, and reduce the water wastage, and also environmental impacts, right? So that's what here you can see. If we have some plants, so with help of different sensors, we can make decisions. Okay, and this will help us out to get the better decision and increase the productivity by reducing the charges. If you are trying to reduce the charge, it will automatically increase the revenue of farmers. And, right? So the only problem, like, I can tell you, being a farmer's son, right? More than 90% time a farmer is always in debt. The reason is his investment cost is too high that getting revenue becomes very difficult, right? So in my own language, my grandfather used to tell me, जो खाना खा रहे हो वही revenue है, बाकी तो ठीक है. Okay, so whatever you are eating, that's just a revenue part for us, right? Otherwise, जितनी लागत है उतनी तो नहीं होने वाली है. So that's the reason we are trying to optimize it with help of different technology, with help of sensors, right? Sensors use precision farming. So let me give few sensors. I'm pretty much sure you are aware of. But being first year, if you're not, let me just scratch the surface so that I should, if I'm going to ask a few questions later on, you could be able to answer it. So I'm going the ways, I'm considering you're not knowing anything, right? Just like me. We both are in the first year of our semester, right? So same thing I'm just going through. Let's assume there are soil sensor. What is the significance of this one? Soil sensor measure the soil moisture, temperature, nutrient levels, and optimize the irrigation and fertilization. Climate sensor, which generally gives the climate details, information. Crop sensors, similarly water sensor and positioning sensors. And there are many more. Okay, no. Let's just focus on this one. Now let's assume I want a device which can give me detail for soil sensors, for soil condition, climate condition, crop, water, and positioning of particular plant. So what I'm supposed to do? So there are different sensors, right? Let's assume there is a farmer who wants all these details in one shot itself. What is he supposed to do?
IoT device.
Exactly. So in that case, what he is going to get? Let's assume all these sensors will be accumulated in one particular device. Okay, and that particular device will name as IoT device, so that it can collect data and accordingly it can send to some required destination, and decision can be made over there. So now I think you can get very clear difference between IoT and sensor devices, right? That's good. So there, so let me just be a bit philosophical over here. So I'm not here to teach you, first of all, right? And to be honest, this sentence I used to do in IIT as well. I cannot teach anyone anything, right? I can just make you think. That's my intention. If by the end of today's session, if you are able to even understand 10%, it's okay. But if you can increase your thinking by 20%, it will be more beneficial for me. So please do ask questions and try to keep open your mind. So at least we are pretty much sure what is difference between sensor and IoT devices. Now we are going to the, as I discussed, there are regions where we cannot move around, where your UAV cannot move around. So there we are saying we'll put different robots, and in technical terms we are saying unmanned ground vehicles. So what is meaning of unmanned ground vehicles? We are saying this is automated vehicle. It's not like you are just going with robot and farmer is taking care of the robot. Okay, I am saying it should be automated so that farmer should not spend their time just operating this robot. So what is this robot or unmanned ground vehicle? So this is a vehicle that operates while in contact with the ground without an onboard human presence. Okay, so we are saying like a robot should move in this particular path. It is not supposed to go in the plant this way or this way. So how can we do it? It's just like saying automated vehicle, automated car. But automated car has pretty much good amount we can invest in. So many sensors we can invest in. But here we need just few sensors so that cost could also be minimized. Okay. So we are to do it, and accordingly we are saying like this. It is similar to meaning to the phrase remote control, so that the person is not available in the field, so he can remotely control it. And this most of the time used by the research and academicians just like us. Okay. And it is most commonly associated with the robotics and mobile robot, but can be applied to a whole range of circumstances in which device or machine is operated by the person available remotely. So let's talk some more parts. So in the previous time we were saying like let's deploy different sensors, right, in different places. But here we are saying let's deploy some possible sensors on this particular robot as well, or UGV as well, so that while roaming from one place to another place they can collect data itself, rather fixing sensor in a particular place. Because while fixing sensor, you are just making, every time I am just going to get data from that particular place, right? What if you are just need data from different places? So then you need to take out your sensor, go and put some other places. So I am saying like whatever details we can get through this particular robots, let's take it out. And this is mobile, it's good for us, right? We are not supposed to take sensor from one place to another place and go and dig around and then take the data. So this is also minimizing our labor cost. Also applying this also creates a weed control usually with machine, and also here you can see there are different kind of sensor could help us out even if you just get the data from these robots, right? Okay, so that automated planting and harvesting could be one of the applications where we can think of. UGV can help us out for reducing labor cost and automating picking and sorting of the fruits or vegetables, right? So those can help us out. So you might be seeing, right, if apple is coming or in the market or something, sometimes they categorize it like size wise. So with help of robots we can do automatically, right? Now coming to other aspects like irrigation management, you can monitor soil moisture level, automate other parts, right? Water where it is mostly required. Data collection and analysis part where we can get the data from these devices, and that will help us out. Obviously, in nutshell, if we say the main notion of this UGV is like labor reduction and cost efficiency, sustainability, mapping and field surveying, field and crop surveillance, safety and risk reduction. So for that reason, we are just going to see the UGV part. Obviously, the outcome is like it is going to increase the precision in fertilization and revenue generation by minimizing the overall cost. Okay, we discussed all three parameters. Now we are just going to combine them all together. Okay, so let us see. Yeah, so let's start with the same thing. We have sensors, we have drones coming, taking data, and there are some places where we cannot collect data with help of UV. We are saying will help robots will try to, or UGV will try to collect data. It looks pretty interesting, right? So collection will give us benefit. It will enhance the crop monitoring, real-time decision making, improve precision, early issue detection, and optimize revenue management. High resolution imaging will be there, that could be help us, that will help us for better decision making. Multispectral sensing, hyperspectral sensors, those will help us out. Thermal sensors, comprehensive data generation, so and many more, right? Optimized irrigation planning, customized fertilizer, component data driven seed detection selection, enhance the soil condition. Okay, so these will be helping us, and at the end they will help us for crop health monitoring and disease detection. And we are saying it is not a disease detection, we are trying to detect the diseases in early stage so that we can be alerted, right? Or so early detection can be done, targeted intervention and continuous health monitoring, predictive yield strategies, right? Reduce input cost, increase crop yield, improve crop quality, higher profit. In the last session, someone asked question, right? What is the benefit of doing all those things? So economical benefit, health development, other things. So yeah, a lot of things are going to happen. Revenue source in precision farming. So because you are in the first year student, right? First year, let's assume some of your juniors, he has just appeared for the exam and he's asking which particular discipline shall he go with, right? Not having very clear vision, you will be in doubt. Let's assume someone is trying to build his career in agricultural domain, like precision farming. So he will say, okay, if I'm just going to do these things, how much money I can make? What could be my outcome? What could be my potential salary after 2 or 3 years? And this will also, this will every time click in his mind, okay, I'm doing BTech, but what about after 4 years? What after 2 years, right? So we should know. That's the reason I'm saying, like, before coming to actual problem, let us see what are benefits we are going to get. Otherwise, if you're not going, पता लगा कि आपकी लागत ही बहुत ज़्यादा हो गई, तो क्या मतलब है? So I'm saying, like, maybe you invested so much money just giving fees and getting 10,000, 5,000 per month salary. Will you accept it? Definitely not, right? So that's what I'm saying. Whatever technology we are going to develop, that should be cost effective. And as per the revenue part, it should be pretty much clear how much revenue we are going to generate. Who would be our customer? Okay. So revenue breakthrough by component like hardware, sensors. Hardware segment leads globally and growing trend in the precision farming in India. Services and maintenance for precision farming presents significant revenue. So let's not just see the Indian context, but see the global context. How other people are doing, right? So I had been in Dubai for around a year and then US for around 1.5 years. So I did not get chance to visit their farmland, but they are pretty much good. Okay, so let us see their revenue part, how they are doing it. Let's take some global precision farming market overview, and so that we can accordingly develop our as well. So there is pretty much good point of saying that we should focus on ourselves, not to others. Okay, but अगर जब आप पढ़ाई कर रहे हो ना, 90% times your parents always refer your neighbors. ठीक है, और वही हम भी करने जा रहे हैं यहाँ पे. Okay. If something is well established, then only we can, because we are not in narrow where we are IT era. Let us see what other people are doing, and can we do better than them by learning? It's not like every time you just go and experience everything, right? ऐसा नहीं कि यहाँ पे जाके धक्का मारो, जरूरी नहीं है. दूसरे के experience कोई और धक्का मार रहा है उसे देख लो. That would be better for you. Okay? So that's the thing I am saying, like, okay, we need to look around other persons, other people across the world, and see what these people are doing and what are their failure and success rate. If we talk about North America, it is leads to adoption of precision agriculture with 28% of farms using advanced hardwares like yield mapping, variable rate fertilizers, and GPS guided sprayers. And European people are also following the similar trend. And Asia Pacific shows the rapid growth with inclusion of like China and India, with inclusion of smart farming or precision farming. And global growth is also significant expansion by 2023 with precision hardware and software. So here is the overall view that we are willing to get by 2030 or 2033, right? 2030. So this is taken by Emerge Research. They published this one. I don't know actually the kind of data they have driven into it. But the only intention I am trying to show, the market is on the right direction. Okay. So if you see, like 35.8% global market revenue was accounted for by North America in 2021. So what could be scenario in 2030 or 2030? Okay. Or 2050, when you will be even more mature enough. So I am saying if you are working in agriculture domain, you are in the right direction. Okay. Even I am from computer science, I am not saying computer science is the best. I am also saying each direction is good. And here you can see one of the examples, right? Okay. Global market by 2031, like USD 9.7 billion in 2023, and projected to reach USD 21.9 billion by 2031. Okay, so we all are on the right track, exploring the concept of precision farming in agricultural domain. So key drivers are need for efficient crop management, reduction in resource wastage, and sustainability. It's another goal, right? Okay, main adopter is like North America, Europe, and Asia Pacific. They are fastly going, and we are on the right track as well. If we talk about the size and outlook, so accelerating 7.35% by 2025, 8.69% CAGR by 2023 to 2028. Okay, so CAGR is like a compound annual growth rate. Those are business terms. Even if you don't know, no worries. You can say just like interest rate someone is going to get from the bank, right? So if they are going to invest something. Okay. Let's forget all these numbers. One thing is pretty much clear. If you are investing in precision farming in today's era, most probably will be benefited in the upcoming time. That's pretty much sure. And we already saw advantages in revenue actually. UAV will give us effectiveness, resource optimization, and many are already available things with us. Everything looks pretty much good. Okay. All theory part I have covered now. Now let's see, being academician, see the challenges. ठीक है, हम लोग वहाँ पे रोबोट रख लेंगे, सेंसर रख लेंगे, यूवी रख लेंगे. अब बताओ काम कैसे होगा? Okay, that known as research challenges. What are challenges coming with these kind of things? And also we are saying every time a person should not go move around and collect data and make a robot mobile from one place to another place. I'm also not saying like person every time just go and fly over UAV, all the places, go and do all those manual parts. So it looks pretty good. This is pretty much interesting, but at the same time it comes with challenges. And it's good there are challenges. Being a academician, this is our job, so that we can get the direction to move ahead with. In precision farming, we have time-consuming soil measurement, path prediction. Now earlier I just shown you the problem because of the traditional farming. Now I'm saying if you are going to adopt the precision farming technique, what are challenges we need to face? Here you can see time-consuming soil measurements. I will come to this part. Path prediction of data collection. मान लो आप 10 हेक्टेयर का है, एकड़ की जमीन है. अब आप किस तरफ से यूएवी लेके जाओगे? किस तरफ से आप drone, which direction you are going to fly with? Which particular place you are going to keep your robots? So accessibility there, path planning is one of the challenges, research challenges. Energy consumption, right? मतलब अगर आपका 10 एकड़ की जमीन है, वहाँ पे आपने halfway your UAV just drained out. अब जाओ वहाँ उठा के ले आओ. हो गया, labor cost फिर बढ़ गया, right? So that part also we need to keep in mind. Quality of sensor data. Whatever data you are going to get, are you really reliable on those sensors? How reliable those sensors are? Coverage range of UV, UJV and sensors, limited battery and data transmission technique. You have deployed W-band, like LoRa that was discussed, or Wi-Fi, or 4G or 5G. What is your communication medium? How you are going to get these kind of details? So these are research challenges where being an academician we can help us out, right? We can design new mechanisms, new algorithms for it. And there are many more, right? These are the few points that I try to highlight for you people, but there are many more. I think this is clear, right? I started with very high level view, then narrowed down. I'm saying, okay, let's come all three components together, but we come up with challenges. Many of you have already highlighted in the previous class, right? Previous session itself. What is battery power, the charge, right? So here are challenges. So how can we overcome this one? This is not pretty much easy challenges, right? If we cannot solve it, farmer can't solve it, right? Okay, farmer can. We need to make a farmer's life easy, not just to keep them in the technical part. So any direction?
For remote charging stations.
There is 10-acre land. How many places we are going to establish remote charging stations, right?
It could be calculated hexagonally using the range of the ground.
Yes. There is one direction. Anything else? What about UAV part? I do not want every time farmer go and just remotely control UAV. Go this particular place and collect data. I want this should be automated. How can it be done? AI algorithm can help us out. We can put path, okay, and path could be directed automatically through the in the UAV. UAV can go that particular direction and collect data and come back. But how this path insertion part be done? Those are research challenges. So I cannot solve all those challenges. I will discuss few of them in today's class. Okay, now I'm coming to the actual part. I hope. So while doing so, let's assume someone is going to hire, some farmer is going to hire, or some person is going to hire this UAV UGV part. But UAV person is not going to deploy their components in your land until they are going to make money. Okay? No, nothing comes for free, right? If you are attending this particular session, someone has already paid it through their taxes. So try to appreciate. If I am coming over here, giving lectures, someone is paying me. Okay? So nothing comes from free, right? For free. Even a single coin, single minutes is not free. You have to breathe around, right? Your breathing is charging you. So nothing comes from free, right? So UGV, because farmer is not going to deploy it, right? Some technology person will develop this thing and they want to make money. Doesn't matter, right, how money is coming. Doesn't matter means ethical way. It's not an unethical way. So they are trying to maximize their profit through the data collection. More and more data they will collect. More profit they are going to make in the whole process, right? In this process, they are saying let's automate with the efficient path planning and minimize the energy consumption so that more area could be covered. And this process, I intend to come up with the algorithm that is randomized adaptive search procedure. I will discuss in few slides. The algorithm will help us out for making this decision, right? So what is the objective? From here onwards, I will not talk general terms. I will talk technical terms from now onwards. So I'm saying like our main intention is with help of UAV and UGV, we will try to maximize data collection part, and with help of efficient path planning. And the path planning should give us the minimized energy consumption, and to achieve these objectives, we'll come up with one of the algorithms known as the modified greedy randomized adaptive search procedure. But again, I need to look the other person's work as well. I have the intention to do something, but what other people have done, maybe someone has already did it. So always keep in mind, let's assume after working 5 to 6 years in industry, you try to come up with your own startup. What is the first thing you want to do? Someone has already discussed ideas, other things. I am not going to discuss on those. First of all, yes, you have to see what other people have already did. What was their success rate? Where did they fall? Okay. Similarly, before coming to this objective, I am just going to look the other persons, right? What other people have done. Generally in the existing works, so what we did, we looked some of the work, like here you can see the references, and we figured out many of the things are missing from the existing literature. LoRa, I think long range radio network, that person already discussed, that is communication just like your Wi-Fi that gives us the connectivity between UAV and sensors, so your data can be propagated from one place to another place. Okay, so here you can see how we are different from the other persons. Okay, challenges comes like mainly focused on existing approaches, focused on predicting path for UAV and utilize UGV for charging UAV. However, data collection based utility maximization is required using efficient trajectory for UAV and UGV. Okay, so let's move ahead. So there are two methods I want to highlight, like graphs and VNS. These two methods I will compare on a method as well. Like greedy randomized adaptive search for closed enough orienting problem. This orienting problem I will not focus much because you might not be able to understand, but I will give the content. If later on you want to explore, you can explore in this direction. And the VNS techniques that attempt to maximize the reward part. Okay, so let us come to the contribution part that we contributed. We means my students and I. So we designed the model like for collecting data from agricultural field sensor using UAV and UGV as a utility maximization problem by minimizing energy consumption while collecting data. And this is notorious problem, right? Notorious problem, like we don't have exact solution for it. Let me put in the simple way. 90% time there is circumstances where you cannot make any decision. You generally used to say Ram bharose ya Allah bharose, right? So in computer science we have a domain known as NP hard. This is Allah bharose ya Ram bharose chal raha hai. Means we don't know the exact solution for it. Okay, for if you are not able to say figure it out, I can give you the notion. In your life, what's your main aim? You are trying to be established after 2 or 3 years or 4 years, right? But what you are paying for it? It is not coming for free, right? You are paying your time. You are pretty much far away from your hometown. You are paying money. These are different things, different parameters that you are contributing. Okay? So, if you try to maximize everything all together, can you do it? That's Ram Bharose, Allah Bharose, right? That part is known as NP hard. If there are so many inputs, you are trying to maximize or optimize at the same time, you can't do it. So you will try to parameterize one by one. For instance, in your case, you are trying to parameterize yourself so that you can achieve your goal after 2 or 3 years or 4 years or 5 years. But at the same time, you are sacrificing your relationships, your family, being very far away, not getting food from homemade food, or you are going through with hostel food, and mess management is doing whatever he is willing to do, whatever he is willing you to eat, you are eating, right? Okay. The same thing we are going to do this one, as we are saying what this problem is pretty challenging to solve. We cannot solve it. But something if we are going to escape out, we can definitely get parameterized solution. Okay. So for example, if you are far away from your home, it doesn't mean you are not getting food. माँ का खाना नहीं मिल रहा है, but you are getting some बाप का खाना. Okay. In the messes. Okay. So that's part we'll see. We are trying to utilize, by this particular process, we utilize the graph. So what is meaning of graph? Like greedy randomized adaptive search procedure. Greedy means something you are trying to maximize one time, right? Okay. Right, and randomized means you are trying to make some random decision, and that decision should give some outcome. And here we are saying adaptive search procedure, that is one. Means you are trying to adaptively search the particular path when UV is going from one place to another place, and that part should be appropriate one. Okay. And we illustrated through the simulation results. Okay. Here is the very basic sensory environment that I am going to consider. Let's assume we have given a particular era where we have UGB, data center, use in cloud or something,
Yes.
where data can come and you can store it. UAV and there are different sensors which are helping us out for data collection purposes. And data is going to the data center where some machine learning, some other algorithms you can imply and accordingly make decisions, right? Now some math is coming on the way because I cannot go theoretically every time. Now let's figure out how can we solve these problems, right? Data collection and while doing all those things. Because we come up with the challenges, right? There are different challenges, and being engineering background people or any background students, I think you are pretty much good. At least 10 plus 12 level math will help us out. And there are few more. So by the way, this particular paper is online available, so no need to take pictures. At the end, I will give you those. Even if you need slide, I will circulate it to you. But I will request at least hold it for 2 or 3 days because I have some keynote as well in some other places, right? So data is already available. I will circulate. I will give it to you. You can circulate among the students, right? Okay, the total flight distance from UAV in a tour is given by. So let's assume there is 1 acre field land, and you are trying to make like what is flight distance? How many hops my UAV should go and collect data from the sensors? So that I already discussed, right? My UAV should not drain in between. It should come back to me. Otherwise, पता लगा drain होकर वहीं पे गिर गया, जाके वहाँ से उठा के ला रहे हैं. So how can we avoid that particular part? We can avoid by strategy. So that strategy we are trying to develop. Okay. So let's assume that total flight distance of UAV in a tour is given by this one. They are pretty simple math, right? Like you say UAV for your purpose. I have just given notion velocity of UAV. So what is speed of the UAV, right? And this like total flight duration. Let's assume then based on that one you can figure out the distance, right? Distance equal to speed into time. Okay, so same thing. Then time required by UAV to reach the collect data from a sensor is given as, this is like कितना data उसको मिलना है, what is speed of data collection, right? Velocity of UAV. And here you can say hovering time. So what is hovering time?
Stationary.
हाँ, जहाँ पे वो जा रहा है वहाँ पे थोड़ी देर रुकेगा तभी data collect करेगा. That's a hovering time, right? What is hovering duration? And how can we collect the distance? Pythagoras प्रमेय, I think I will say this one. So not Pythagoras. This is known as a Euclidean distance, right? If you have already given coordinate, you can figure it out, right? So everything is okay, right? We can find out the flight distance. We can say like time required UAV to reach and collect data. If you are already aware of, accordingly, hovering this time we can find out like time between transmission time. Transmission time means, so these keywords I will be using later on as well. So that's the reason I am trying to clarify from here onwards. What's the meaning of transmission time? Let's assume there is sensor. Sensor is sending data to the UAV. This is completely computer science thing, but I will try to get it. Simple meaning is like इतनी देर में वो sensor data UAV पास भेज दे रहा था. There are many more terms. I will not make your head with those technical jargons. So simply, right, how many time it is taking to transmit data from the sensor to the UAV. That is known as transmission time, right? So this hovering time said like minimum between this transmission time and TD is like duty cycle for the LoRa receiver. So what is this one? Let's assume you are sending simple. You can say when you are going to upload your WhatsApp status message. Very simple, right? It just go in the chunks, right? ऐसा नहीं कि आप 1 GB डेटा आप अपलोड कर दो स्टेटस में, नहीं आता है, 4-5 बार नहीं आएगा वो, ठीक है? Similarly, when you are going to transmit data through the LoRa technology, so what is LoRa? Just like your Wi-Fi, you simply say, okay, this is used because this longer duration, maybe as person was saying like 1 year or something, right? So saying like by what capacity it is collecting data from the sensor in between UAV. Between UAV and sensor who is working this LoRa technology. For example, if you need to transmit data, you need to open your Facebook or WhatsApp, you need Wi-Fi, right? अब कितनी देर में वो data upload होगा, ये Wi-Fi की speed depend करती है. Similarly here, how much time it will take to transmit data from sensor to UAV depends on the speed of the LoRa technology, right? That much only. We are saying the utility of UAV is calculated. So what is utility? As I said in pretty early stage, nothing comes for free. As and when a farmer will deploy all UAV, he will manufacture UAV, he will do UGV. He is not going to do it, right? He will take help from different UGV provider, UAV provider, right? But UAV provider is going to make money. On what basis is going to make money? This based on this one. Utility. And on what parameters it depends? It depends priority of the data or hovering location and this one. What is this one? Hovering time. Okay. So amount of data collected in the hovering time and what amount of data he has collected. So what is meaning of priority? Let's assume hovering time is 1 hour or something. UAV service provider comes in picture. He said like I will collect data for 1 hour. Give it to me. Is it really valid statement? This is not valid statement. Maybe he will just hover at one position, collect all data from one position, right? But when he is giving contract to the farmer is giving contract to this provider, he is willing it can collect data from all corners of the field. That is meaning of priority. It should not be same data. It should be different data from different points. That's the reason you see this utility part is playing a role over there. Putting priority as one of the parameters. Okay. So similarly, the number of location he is going to cover data, utility of UAV will increase. Okay. So we get how UAV person is going to make money. It's clear, right?
Sir,
Now,
sir, what in terms of what is this priority calculated?
priority I have just given notion. It is simply saying, let's assume you have 1 acre land, right? To avoid the notion of getting data from same location every time, I am saying each location has given different priority. So in terms of, let's assume you are here. There is a land is available somewhere very far. So the land corner, let's assume if you are starting from here, and the corner you can see, right? So priority of this particular corner we are giving lower compared to priority given to the
Is it distance?
distance basis. Why I am saying so? The reason is because traveling longer distance will charge him more. Okay, so that's the reason. Why would someone go longer duration when he is going to get same money? That's not right. So that's the reason. So we are saying proportional. जितना उसने एनर्जी कंज्यूम की उसके हिसाब से उसको पैसे मिलने चाहिए. The utility but in this process he is going to make money, but at the same time he is going to get charged. By what meaning? His energy will drain. So that's what we are doing. The total cost of UV for traveling to each hovering location in a tour is defined by this particular equation, and this equation gives idea of the different location he is going to collect the data and how much energy is being, its cost of collecting data from sensor in a tour, and this is proportional to the energy consumed in collecting the data, in data collection, and this is travel for collecting the data, right? So these equations are clear, right? I see, if I have any doubt, please ask a question, and if you don't have doubt, then start doubting on me. Okay. So the reason I am saying these are pretty standard formulas, right? And teaching something for first year is pretty challenging for me as well. So that's the reason I am saying if you are getting any kind of confusion, please ask a question. UV part is done. Now we are going to UGB. Okay. So total utility of UGB, because UGB person is not going to give a free of cost, right? So the utility of UGB is calculated using this equation, which is taking care of amount of data collected and priority of moving locations. Right? Is it clear? Okay. So overall utility say how many places he is going and collecting data. Accordingly he will get paid. Okay. If you are able to get this one, then this also depends on the energy part. So you can think of some other portion, but I consider the energy. Okay. So here is the problem formulation. So the objective of the proposed, it is not so the objective of the proposed model is to maximize the utility of UAV and UGB with minimum energy consumption given as this one, UAV and UGB utility divided by their total cost. and we are trying to maximize. So that's the way, so more and more revenue could be generated. And total budget constraint is also given over here, and energy constraint and energy constraints are also given here. Okay, so that my UAV should not stop in between and my UGV should not stop in between. So we need to make such strategies. How difficult this problem is? So this is very difficult problem, as I already discussed. This is NP hard problem, but I will not go in those details. Okay, this is completely computer science and maths people cup of tea. So, but let's forget this is very difficult problem. Just like saying I cannot optimize everything at one shot. So I am just going to parameterize one by one. Okay. So to solve the problem, we come up with the proposed solution. Here is the algorithmic form. This is like we are just going to set of agricultural IoT sensors in the field. Then we are saying which particular sensor is being covered by UAV and which particular sensor is being covered by UGV. On what basis I can make decision? If some person is not being pretty much okay to cover by UAV due to the geographical location or something, I will circulate UGV, right? Okay. So after making that decision, we are trying to figure out the optimal path for UAV and UGV using modified graphs algorithm. I will show you what is this one. And we are saying like calculating the utility and energy cost. If cost is minimized, we will stop, otherwise we will just keep on iterating. And once we get the best possible cost, we will stop over there. Right? This is the algorithmic flowchart, and here is the bombarding pseudocode. I will not discuss this one. Okay. So I will not discuss this. This is pretty easy, but it will take time to. If you might have in the third year, final year or somewhere, I could have talked about it. But this is algorithm, and this is simplified version. I think by this one you can see. Okay? This is given in the. I am creating graph other parts from most probably in the next session. I will discuss more on those technical parts. Okay, I started with problem formulation. I come up with the algorithmic solution. Okay, now what? Simply, you come up with your idea, you implemented your idea. Then what is next? You have to see your padosi, right? Your neighbors. So I need to compare on some parameters saying that, hey, my idea is better than yours. Right? Otherwise, no one is going to take your product. That's pretty much sure. Exactly. Why did you select this particular college with having an IRF ranking 10? There are many more colleges as well. Right? Okay. So similarly, we are saying we have to parameterize something, accordingly make decisions. So in this process, I am just going to compare with two methods, GRASS and VNS, and this is parameters that we have taken. And unluckily, we did not get Indian agricultural data at that particular time. This paper was published around 1 year back. So we used already freely available data set from US Agriculture Department website. We have taken from there, and including sensor count, measuring depth and field sensor location. And here you can see the other parameter, number of sensors, sensor data size 22 to 38, number of sensor 10 we have taken, UAV, UJT 11, and other parameters are given over here. So we compare our model with the other two methods on several parameters. Few are shown over here. Iteration and average data collection. Iteration should directly proportional to my proposed algorithm. Means how many number of times my algorithm is going to iterate, so that I come up with the solution part, right? And average data collection, how much amount of data is being collected in whole process. Okay, so here you can see the trajectory or trade-off between average data collection and iteration. As the iteration increases, the average data collection goes down. It simply says when in the first iteration more and more sensors data is being collected with help of this particular algorithm. In the subsequent sections, once data is being collected, then those sensors are discarded from the iteration and being taken care by the rest of the sensors which data has not been collected, right? And here you can say we perform better than the other available methods, two methods, right? Proposed and graphs. Similarly, in the average utility part, with respect to iteration, we got the better utility.
We actually comparing to the, the
No.
already
I claim that minimize cost with respect to my methods. I did not say anything with respect to other methods, right? So now with comparison, I am saying with respect to other methods, right?
अगर हम कोई चीज़ क्लेम करते हैं ना, फिर वो प्रूव करना है हमें अपने ही मेथड से, वो है ये तरीका। तो पहले क्लेम
So
करना
like you
पड़ता है
said,
फिर उसी के
Yes, sir.
farmers are usually, old age people and
No. That's no. I didn't say that part. No.
you said you gave reference to your father, right?
I said my grandfather used to say when he was quite young, right?
Okay, let me rephrase it. So, do you think that there is any challenge when we take technology to the farmland?
Huge challenges, right? I think some of the challenges have been discussed by the previous one. The challenge is like, see, do they economically good enough to take that particular technology? Farmer.
So, let me ask the question differently.
Okay.
How many farmers in India would have calculated the production cost that they incur on say 1 acre of land?
They can't do it if they are not smart enough. Okay. So
let's
someone
take-
has to do on behalf of.
So how do you think that can be done? So
That
I
can be
am
done, sir.
roaming around in the farms of Kashmir. Kashmir is a cash crop rich land. Okay? We have a cash crop, that is apple. So most of the farmers in India are not earning that much money if you compare it to Kashmir. Okay? Even here also, people don't know how much one tree is producing and what is the cost they are putting into that tree at this point of time also. We are in 2024. If you ask any high density apple orchard owner also, he would not be able to tell you how much he is, utilizing. What is the input cost of his orchard? So when we take technology to the farmers, the first problem that we
They
face is
they won't accept it. Believe me. Now, if you complete it, I can start.
that's what I'm trying to understand. How do we, overcome this challenge of making people understand? Even illiterate people are good businessmen, right? You don't need to be a PhD or a MBA student to do good business. Illiterate people also do business. So how do we overcome this challenge and make them understand this technology is going to benefit you? I understand we can show these PPTs to them, but if we can take up a model village, for example, say any village in XYZ in Kashmir division, and we try to implement these technological implements on that particular village, then we will have a solid model to show the rest of the country that this is a neighboring village and this is the village where we have implemented all these technologies, and this is the difference between the yield here and the yield here. So this is something that we need to do. Otherwise, it will be very difficult for making people understand how it works.
That's the ground reality. Now just think about. Let me give this one. Why do you think this particular agricultural institute is here, not somewhere in a high-tech city?
It's here because there are people who are benefiting from the research that is being done here, and because we are making good money, government thinks that this is where they need to put their resources so that they can increase the inflow of money again.
Exactly. If you are being evident by the farmer, so simply they will not understand our jargons, right? Technical jargons they are not going to understand. Why should they understand it? Because they are forefathers or persons who are doing the same. Now convincing them, saying that, hey, whatever you are doing, we are also doing at our institute. Whatever you are producing in 1 acre, we are doing within half acre. Why don't you just come and we can increase your revenue? Definitely they won't listen to you. But somehow convincing them and asking them to at least just visit and putting some effort, okay, maybe lubricating them, will make them think in our domain. Yeah, this institute has these things. Within this region only they are earning so much revenue. Maybe they, that particular domain, they will give you the consent and they might give you their agreement.
So there are actually a lot of players involved, right? So we have input agencies, input companies like IFCO, Syngenta, UPL. They also have interest in what is going on the ground. So we also need to connect with them.
Let me, before we start finishing this one, I just want to lubricate same fashion I went through.
Yeah.
I started with very jargon related topic. So this will maybe give some notion. Right? A hugely technology oriented topic. Right? Nothing to do with the farming. They are not pretty much caring this one. Then I tried to say something about ITBHU. Then I tried to come up with these beautiful pictures. I'm saying if you are in the particular stage, for whatever reason, and if you want to reach this particular stage, it's your choice.
Right.
But this is not just one night work. I cannot make you from here to here. It's not like just tuning face and you can get it, right? So to make this one, we need to adopt this one.
Correct.
So if we convince them, if you are in this particular phase and willing to come this one, I think if it's simply asking farmers, can we increase your revenue? Definitely they will say yes. But once you are going to say, okay, I will do this one, this one, this one, they will say no. Simply saying, if you are getting a call from any bank, first they will say, we are giving free of cost loan. Now you just peel it out. Hidden charges, this one, that one, that one. But still, you will be engaged with the bank agent until you feel like something not weird happened. So that's the reason if you see, I tried about this one, this one, this one, this one. Then I said like, if you are going to adopt this particular function, we'll make such kind of revenue. Now you get convinced, stating that this gentleman is going to say something which will make money. Industries people need to convince the customers, like farmers. We can't do it. Right? Very nice algorithm, 0.01 millisecond even in executing, they don't care. But who is going to care? Who is going to develop this particular technology? At least we can convince them. And once we are able to convince them, they will convince the farmer. Because they are very good at business level. But we cannot convince, that's pretty much sure. Okay? Okay, so distance and average cost. Okay, I think and time, budget and utility, we got a bit better, right? Now I will just show one of the very short video where will not apply actually whatever we discussed, but a very short video I will show you. Let me show one of the videos by my students. I will directly come front. I think there is no music, so or something. So the requirements here you can see that we are talking about jumper wires, LoRa radios. Then we are going to connect it all together. Yeah, so something looks like this. So power supply, LoRa shield, and their configurations are given over here. So question comes how we are going to upload code on this testing setup. So at the end we are storing everything on the cloud. So let's see the procedure. So here is just two things, right? Temperature sensor and humidity sensor. So it was done in real time. So this real time data is being collected over cloud. And I will show the actual sensors that are helping us out in a few seconds. So we have drone setups, which is so here we have drone and we packed LoRa shield, hotspot, mobile phone. The mobile phone is actually working as a data collector here. So here you can see one of my PhD students here is trying to put everything in the box, and with the help of this box we'll try to collect the data. So now we are just going to fly our drone, and sensors are located on the ground through which we are continuously getting data. And that you saw the video, right? Where data was collected. So we can for this one we are collecting those data. So this is our beautiful campus, ITBHU. So this is being done in real time only. So this is the humidity and temperature data that we collected. But we did not make any decision based on this one. But what I'm saying, this is doable, whatever we predicted, right? Okay, in even real time. So here is the conclusion. The conclusion says like we formulate a total utility maximization problem, and this was pretty difficult to solve. Then proposed a heuristic to solve the problem, and we also find something better than other available methods. And there are many more available approaches that could be employed in the future, like finding our suitable machine learning model, analyze the data collection, and predicting the health, environment, condition of the crop at real time. And these are few references that I've gone through. And here is the paper that you can think, the last one. If you just download it, you can get this, whatever I discussed in today's class. Most of content you can get from me. And these are my details. And I humbly request, ask at least one question.
Sir, I feel that this data collection process, use of UGVs would be a better approach for longer distance.
Right, but yeah, that's better, but we did not do that particular trade-off part. But we cannot completely rely on UGV because there are places where you cannot ask your robot to go and collect data.
Sir, usually agriculture land is in plains.
Planes, right? But what would happen if your there is no particular path? Which path your UGV is going to follow? मान लो गेहूं की खेती है, ठीक है? Fully congested है, आप उसमें रोबोट ले जाओगे, मतलब उतना खराब कर देगा. Depends on case to case basis.
Sir, what was in the last video, what was the function of the drone? You said that the
Just collecting data. Sensor were implanted on ground.
Can we not for example, forgo the drone and connect it straight to the server or something?
We have done it that part, right? Server we have connected right? Directly in real time we are getting data on cloud.
Then what is the function of the drone?
Drone was just going and taking away data from different places and helping us out for taking data from ground level and sending it to the cloud.
Can we not just forgo the drone in the process and just connect the servers with the cloud?
That we can do, but what is capacity of these sensors, devices that can send data? Can they send 10 kilometers? Or can they send even 500 meters? That's not possible. We are trying to enlarge the connectivity part. That's the reason. Any other questions or suggestions? Yes, please.
Can we also develop a hybrid kind of a system? We can utilize the data of a traditional farmer, of his expertise he has gained over last whatever the years, and well as the data we are collecting by our means.
Yeah, that's the reason. That's the reason your institute is hiring computer scientists as well. You're collecting data. Now they will, oh, I have data, go and apply CAIML and give me a decision.
Sometimes the data we are collecting, it is
Non-proper format?
we can say it's the data we are collecting nowadays. But the farmer who have been doing this farming from last 50 years or say that 40 years, he might have some expertise which we do not know.
Yes, right. That part I will discuss in the next session. And we will try to lubricate farmers in that particular case, right? Why someone is going to give us data even? Farmer क्यों अपने खेत में सेंसर लगाने देगा जाके वहाँ पे खराब करोगे तो we'll discuss in the next class, right? Any other questions or suggestions where this method can be improvised? I already discussed like we can apply the analogy and analytical models which can help us out for betterment of this methods. Anyone? Okay, thank you everyone. See you in the afternoon. I have some light lunch so that we can awaken more. Okay, thank you so much.